The final spacecraft to ever touch down on Venus marked the end of a long series of attempts by the Soviet Union to investigate the most hostile environment in our solar system. Here is what those missions discovered upon landing and the reason humanity has not returned since. The true puzzle of Venus lies in its profound similarity to Earth in some ways, yet its catastrophic differences in others. While Mars captures much of the focus today, during the early years of the space race, there was significantly greater interest in studying Venus. This was largely because astronomers could easily observe the Martian surface through telescopes from Earth, giving a clear picture of a relatively quiet world. Venus, however, has always kept its secrets hidden behind an impenetrable veil of thick clouds. While these clouds block our view, they also reveal something crucial. The planet must possess a dense atmosphere, far more like Earth's than Mars's. Given Venus's closer orbit to the Sun, it was logical to assume it would be warm there, sparking imaginations on Earth. Perhaps our nearest planetary neighbor was a lush, tropical jungle teeming with strange life forms. Even by 1960, this remained just a theory, though considered more plausible than life on Mars. The prominent astronomer Carl Sagan had already popularized the idea that Venus's unbroken cloud cover was likely the result of a runaway greenhouse effect, superheating the planet into a scorched wasteland. Only one method could settle the debate. As with many early space race milestones, the Soviet Union moved first to study Venus up close. It was 1961, and the Soviets held a commanding lead, having launched the first satellite Sputnik and the first human, Yuri Gagarin, into space. They had even been first to reach the moon with Luna 2. Targeting Venus, the next closest object, was the obvious progression. In that era, these missions were less about pure science and more about achieving historic firsts for propaganda and political gain during the Cold War. Aiming to add Venus to their list of accomplishments, the Soviets built two probes, Venera 1 and Venera 2. It was common practice then to launch missions in pairs due to the high probability of failure. The ambition of these early flights was staggering. Guided by little more than calculators, engineers attached a rocket engine to a probe, launched it atop an Ara-7 ballistic missile, and pointed it toward Venus, hoping for the best. Both probes flew within 100,000 kilometers of the planet, but each suffered a complete systems failure before arrival, returning no usable data. While the Soviets regrouped, NASA proceeded with its own mission. In 1962, America's Mariner 2 succeeded where the Soviets had not, flying within 35,000 kilometers of Venus and completing the first close-up observations of another planet. A 42-minute scan gathered critical atmospheric data, confirming Sagan's greenhouse effect theory. Temperatures soared to 459 degrees Fahrenheit, double water's boiling point, and this was only from orbit. Mariner 2 also discovered an immense cloud layer stretching 80 kilometers high, on Earth, that would mean clouds from the ground to the edge of space. While the surface remained hidden, it was clear nothing could survive there. Based on these findings, NASA largely abandoned further Venus exploration for the time being, deeming it utterly inhospitable and shifted focus to the Moon and Mars. The Soviets, however, were undeterred. Stepping back saw an opportunity. They prepared a second wave of Venera probes, unaware of the severe challenges ahead. By 1966, the space race landscape had shifted. The Americans had caught up, and landing humans on the Moon was now the top priority for both nations. Yet the Soviets had not forgotten Venus. They spent 4 years building larger, tougher spacecraft. Venera 3 and 4, now weighing over 900 kilograms. These probes carried instruments like barometers, radar altimeters, gas analyzers, thermometers, and a detachable descent module designed to parachute through the atmosphere, taking readings all the way to the surface. Reality proved complicated. Venera 3 suffered another systems failure en route but still struck Venus, becoming the first human-made object to crash into another planet. The USSR had now achieved impact landings on the Moon, Venus, and Mars. Venera 4 in 1967 came closest to success. The probe reached Venus operational and released its capsule into the atmosphere. The descent module deployed its parachute and drifted down, becoming the first craft to collect atmospheric data on another world. The readings revealed something intriguing. At high altitudes, Venus's atmosphere was quite hospitable, akin to a warm summer day on Earth. But as the probe descended, conditions grew extreme, with temperature and atmospheric pressure skyrocketing. Like diving deep into an ocean, the air grew thick and heavy. After 90 minutes of descent, transmissions ceased. The capsule was likely crushed by the atmospheric pressure. Armed with this new data, the Soviets were almost certain their next probes, Venera 5 and 6, identical in design, would not reach the surface intact. They launched them anyway in January 1969. By this time, the Americans had flown a crew around the moon and were preparing to walk on its surface. The Soviets knew they could not match that, but a breakthrough discovery on Venus could keep them competitive. Success remained elusive. Both probes recorded less than an hour of data each before being crushed like their predecessor. Still, the Soviet Union refused to give up. They would build bigger, stronger probes and try again. For Venera 7 and 8, engineers made two key modifications: a thicker steel outer shell to resist pressure and an internal titanium sphere with padding to protect instruments from heat and impact. This was wise because when Venera 7's parachute deployed on August 17, 1970, it quickly failed, ripped, or melted. The lander dropped like a rock, hitting the surface at about 61 kilometers per hour. Observers on Earth assumed another failure, but the damaged lander with a busted antenna kept transmitting. Venera 7 confirmed scientists' worst fears. Surface temperatures reached 475 degrees Celsius, as hot as a wood-fired pizza oven, far beyond reliable operation for any machine. The Soviets persisted. What did they have to lose? America had planted its flag on the moon, winning that race. But the Soviets could still make history by being the first to make transformative discoveries on Venus or Mars. This became their focus in the 1970s, interplanetary exploration. In 1971, they achieved the first soft touchdown on Mars, though the lander operated for only 20 seconds. In 1972, they returned to Venus with Venera 8. Miraculously, this probe faced no technical issues. Its descent module parachuted softly to the surface, instruments intact, and recorded data for nearly an hour. By now, the horrific conditions were fully understood. Extreme heat, atmospheric pressure 92 times that of Earth, equivalent to being 1 kilometer underwater, and an atmosphere laced with sulfuric acid, the corrosive liquid found in car batteries. One might think this would deter even the most determined engineers, but the Soviet Union did not believe in quitting, not when they were so close to securing their legacy as pioneering interplanetary explorers. They set their sights on Venus once more because Venera 8 revealed one last tantalizing fact. Despite the dense clouds, enough sunlight reached the surface to take a photograph. Success would mean the first picture ever taken on another planet. For Venera 9, the Soviets fundamentally redesigned the probe. The descent capsule was strengthened further, bringing the total weight to nearly 5 metric tons, about as heavy as a full-grown African elephant. The most notable changes involved a new landing procedure. Knowing the environment's brutality, they wanted to minimize the probe's exposure. They also learned from Venera 7's accidental freefall survival. So what if they simply dropped the probe on purpose? 2 rings defined the new design. The bottom ring was landing gear, a flat metal circle connected by shock-absorbing legs. The top ring was an aerodynamic brake, a weird hat-like device that used Venus's incredibly thick fluid-like atmosphere to slow the craft enough for a safe landing, no parachute required. And the cameras. This is the first photograph ever taken of Venus, captured in black and white by Venera 9 in 1975. It shows a field of jagged, broken rocks surrounded by sandy material. The image itself is not breathtaking, its significance lies solely in its origin. Venera 10, an identical lander arriving days later, sent back a view of flat ground with smooth rocks, likely the top of an ancient lava flow. Venera 11 and 12 were less eventful, failing to return photographs due to lens cap malfunctions. Protecting the camera during descent was critical to prevent melting, But the automated system to uncover the lens did not always work. Then came Venera 13 in 1981, an unlucky number for a highly successful mission. It returned the first color photograph of the Venusian surface. Again, the immediate area was flat, sandy rock, but a hint of landscape beyond was visible. The probe landed near a cliff edge, offering a sense of depth that made the scene feel both more real and more alien. The lander's base is visible, and you might wonder about those tooth-like structures. They served an aerodynamic purpose. Metal fins added to the impact ring to prevent spinning and shaking during descent, ensuring a smoother landing. Venera 13 did more than take pictures. It carried a drill to sample the soil. Analysis revealed material similar to terrestrial tuff, or solidified volcanic ash. The probe also carried a microphone, capturing the sounds of Venus, mostly wind and the probe's own operations, yet undeniably strange and otherworldly. Venera 14 was nearly identical, finding another flat plain of smooth rocks determined to be similar to toliitic basalt, a volcanic rock common on Earth's ocean floors. And that was the end. No human-made object has touched the surface of Venus since. That mission also provided the last photograph ever taken from the surface. So why did we never return? One clear reason is the immense effort and expense for relatively little return. A robot on Mars can operate for years. The longest a Venera lander survived was about 2 hours. The Venera program concluded as the Soviet Union itself was ending. Leadership and priorities shifted, and Russia faced difficult times in the 1990s. Meanwhile, NASA has seen little justification for the cost of reaching the Venusian surface, knowing the meager returns would be a hard sell to politicians. For now, the surface of Venus remains one of our solar system's greatest enigmas, so tantalizingly close, yet so frustratingly far. If you found this journey through space history fascinating, help us explore more mysteries by subscribing to the channel. Your likes and shares make a real difference, allowing us to bring you more incredible stories. A real difference, allowing us to bring you more incredible stories.